Leo, this is the third session. So, like I was explaining to you, we imagine that we have this kind of plates, and we already agreed that if we have these 4 plates on top of each other, Leo, can you follow up?
Yes.
So we are not able to get the first plate unless we really take out these plates number 2 and 3 and 4, right?
Yeah.
Okay, so this is how it looks like here. And actually, a stack is actually used inside the memory of the computer. So it means that when you are inside the main program, this is, let's say, main, and you have find maximum function that is defined here, and it takes some parameters, and this is the place of the function. You have a return value here. So what happens, Leo, that as I said, the program or Java in this case use the memory to store your variables that you create. So inside here, for example, you have integer x and you have integer y, and then you have find maximum, and you are passing x and y to your find maximum function. So what is done actually is that whenever you have a look at the memory, you will find that, oh, x is defined. After that x, another memory, a following sequential memory location is called y. And then when you pass find maximum, which takes number 1 and number 2 here, and it do some operation, whatever the operation it is, so you will find that, oh, the computer internally is creating number 1 and number 2 variable here, which is if this is here 10, here 20, they create another copy of x, pass it here, another copy of y, pass it here. Okay, and if we define Boolean and we say result here like that, and we give it, for example, true. Okay, so I will define here result, and this result here I put true. So the more variables I need to create, I will keep incrementing or going deeper inside the memory. Okay, and keep creating. I'm using the memory space here, and I'm somehow adding more. So adding more variables as you define here inside your function. So what you do here that you actually don't really go and access x and y when you are inside your find maximum function. So the more you define here, you actually start to access the memory location that is starting from here somehow. And then when you do your job here and you finish your job inside find maximum, you start laying down the variable as you use it, and then before you exit that function, or upon exiting that function, you will start to release the memory location one by one until you come here to the position that, oh, you already managed to finish find maximum, and then you start to execute whatever here. So you come back to that place, the original place that you left. So this is something very close to the stack. So what I want to say is that, yes, this is a plates example. . . 。  . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . okay? And inside the memory, we're using also the same concept of a stack. So we are assigning variables inside the memory in this way, okay? And we are not inside maximum, we are not able to access all the variables that is created in the main. And when we are in the main, we are not able to access all the variable inside that function. So this function is defined, it have its own variables that is local to it. So that is something similar to stack. I know it's a bit far, but this is how it really works inside the memory. I'm not making assumption. This is really how it works. Did anybody explain it this way before to you?
No, I don't think they have.
Okay, I would like to ask you, did what I explained just now, what are you able to understand and what is difficult to grab?
Well, I think I get what you were. Well, I think I got most of it.
Okay, so you managed to get what I'm trying to tell you, right?
Yeah,
No
yeah,
difficulty? Okay, good.
yeah.
So, what can you remember about the queue?
Well, it would be of the other way around. So it's like first in, first out, kind of thing. So it's like
Can you
well, for
give me an
stats it's like
example?
plates, but
Can you give me an example in real life of a queue?
I can't really think of anything. Oh yeah.
So, where do you hear that kind first come first serve?
Buffet, restaurant, that kind of.
Yes, yes, perfect. So you can remember it this way. Queue is first come first serve. And if you are in a school and the school have a printer and a few students are trying to print some documents for them, so the printer inside it and the operating system inside, I am assuming that the computer is a network. Sorry, the network is the printer is a network printer. It means that it can receive requests or print requests from many computers at the same time. So inside the network printer, there will be a queue, and this queue actually have to serve the first document that is sent to it first. So the first person who send the print command, his document will be served first. His document will come out first to be for the printing, and of course it makes sense, right?
Yep.
Okay, good. So I think this is the easiest way to remember how what's the main difference between the stacks and the queue. So let's continue on the stack until we talk about the code about it. So this is how we push. I think so. The push command actually worked like that. So if there is an item, we issue a push command, so it will push something on top of one. We push here, we issue another push command, so it will put something on top of the old or the original stack, and then we push 4. So here, this is the stack, and we are pushing. We're calling the push command again with 4, so it will put it on top, and so on. If we issue pop, so it means that okay, once we issue pop and we pass it 6, so it will take out the 6. The only issue here that when we issue pop, actually it will totally remove it. So it means that you have barely a chance to even look at your stack. It's very hard to look at the stack. What's the meaning look? So if you want to loop through a stack to know its content, uh, you have to, there is no other commands other than the pop. It means that when you just issue a pop for 6 or just issue any pop statement, it means that you are actually removing something out of the stack. So you just actually wanted to look what is inside the stack, but by issuing a pop, you actually removing from the stack. The more you issue another pop a function or method, you are removing more and more and more. Yes, you are able to store whatever you get out of the pop. So if you issue pop like that and you put X here, so whatever comes out of the pop can be stored here in X. But again, as I said, yes, you can store it, but you lose it from the stack. The stack no longer have whatever you popped out. Does this make sense to you?
Yes.
Okay, so there is a library, a standard library, same like the one we have seen in the linked list. There is a standard library from Java that can help us to implement this stack. And this is here, Java util.stack. So this is how we define a stack. So we can define a stack of integer, we can define it of strings, or we can even use objects. It's fine also. And this is how we use push. So you are able to use a lot of push statements here as you wish. And this is something extra, but I just would like to ask you, do you understand what this code is doing?
So it's creating a new array with like the same size as that of the stack.
Mm-hmm. But you dealt with arrays before. You already taken arrays, right?
Yes.
Okay, good. And do you know what's the difference between integer in this way and int? Most of the time we have been using int, right? We never use
Yep.
integer this way. Okay, so you don't know what's the difference, right?
Yeah, I'm not sure.
Okay. Okay. You didn't take primitive data types?
Primitive data types.
Did you hear that word
I've
before?
heard the term, but I'm not exactly sure like the exact definition of it.
Okay. Okay. So I will cover that, but let me focus. I don't want to lose what we are doing on the stack, because this is so that line is just an extra line. Okay, this is just an extra line. It means that not necessary that you will need it. Just in case that you will need it, then you already know how to do that. But I don't want to push extra information that high chance that might be you will not need to use it. So the thing here that what this code is doing is that it is popping out items in the stack, and it is inserting it inside the array. But I would just wonder with you, if we pop out things from the stack, what do you think? So do you see what this guy is doing? He identified or defined an index, and every time he inserts something here, he is going to increment the index. Have you seen something like that before?
Yeah, I have.
Okay. And do you think he will insert inside the index 0. So this means that array 0 will have something, or he will start from 1.
Yeah, I think it'll start from 1.
Mm-hmm. Okay. I will not comment, but once we finish this portion, you can try that and see what is the difference. But I would like you also, after you try that, I would like you to put ++ index under. So after you try that, you will try to put the array like that and put inside the square brackets ++ index and see and compare what is the difference. Okay, so after you do that, what is happening here, the most important to me to understand. Now, this pop command will get 5 first or 1 first. So the first, if I were to insert at position 0, or if in position 1, I will insert the 5 or the 1.
If you're popping, the 5 would come first.
Yeah, perfect. That's good answer. Okay, good. So it means that we are inserting inside the array in the reverse order, right? So we will insert 5, then 4, 3, 2, and 1 like that, right?
Yep.
So this is how I think it's easy for you. If we look about looping inside an array, this is one of the ways that we can loop through. I think it's easy, and this is not related really to the stack. But the most important before we leave, did you notice stack dot is empty?
Yes.
Okay, so we have seen now 3 things that we can use: push, is empty, and pop, right?
Yeah.
Good. That is also clear. So this is another way to convert a stack to. If you see that line, do you really understand what's going in here?
So 2 array, that would be like so is that just like a method that converts the stack to an array, like to the array?
Directly in one line, yes, without looping. Yes. Okay, good. And this is how he printed. Again, this is something extra. I believe you would not really need it. But so my thing here is that I would like you, this is an exercise, I would like you to write to me a method. How can you display something from the stack? Okay, so not something, just all the contents of the stack. We are not going to use how to say integer or string. We will still use the students object. Okay, so you will create a stack of students, and I will pass you some code so that you don't have to write the information that you need to stack inside or insert or push inside the stack. I will give you that, and your job is just only to make a loop inside display stack that actually try to print whatever information inside the students. So you can print the name and possibly the age and the grade. Okay, so I will pass you the code and this slide, and let's see. So I will stop the share, and then you can.
How do I share? Yeah.
Yes, you can start sharing. So this is the code. I already passed to you the code that you need to write. I'm defining the stack and inserting information into it. And yeah. My worry is about this the student, because you don't have the class student yet. You want me to copy it you?
Yes, please.
Okay, I did.
I think I can copy it from the.
Yes, you can download it, yes. Or you can copy it also.
Is it the same student class as before? Or oh wait,
Exactly
no, it would be a stack.
the same.
But I'd have to change it to a stack, right? Or
Sorry again, what do you say?
just the
The student class is exactly the same. But
this one?
yes, but you didn't. You have to rename it to .java, and I mean the file name. You have to right click here.
Oh,
You didn't. Yeah. the file that you created here is, yep. I would say you come here. Once you come with the mouse, right click here. There is, yeah, rename. Yes, press enter.
Would that work?
Yes, it should. So try to run and see.
Well, I think it worked, but it didn't print anything because it didn't put any like print.
Okay, so yes, you didn't put any print, so it will work. So just focus on displaying doing the function that display the content of the stack. So basically, pop does not take anything. So it's just an empty thing. But it's good that you do a print statement so that things are. So what you wrote, Leo, are you confused?
Yeah.
So students, dot pop will get you out something. So continue putting it in the print and then run so that you are able to see what you are getting. But just you will not print anything because you didn't call yet.
Oh yeah, because I didn't call it yet. I think I called it wrongly.
Something is not correct. You're passing the stack here correctly, but when you are popping it out, let me see here. This is just printing the somehow the memory address, but that's not correct. I want to figure out why. Let me see here. Student stack. Can you try to so in a way to troubleshoot, we want to know the problem is here or from this side. So I want you to put this print statement actually here. I want to see if this tag is the one that's having a problem or
Wait.
okay. So can you tell me what do you think? What could be the reason for what the error that we are getting?
Well, if I try to print and just put plot, then the only thing that will return is the address and not any of the like actual variables stored within the stack.
No problem. So I am passing you a code. Please copy that code and try to do somehow printing or popping uh, using that integer. So now we are not going to use an object yet. Let us try on a simple thing and see how it looks like. And no, I would like you to make a print statement exactly same like that.
This
Okay, yeah. But just correct this. Yeah, okay, you are correct. So can you tell me now why I managed to print something here, but on the previous code I'm not able to print anything. Here I'm not able to print, but here I'm able to print. So put another pop, please. Put another pop under it. So copy that line 27 and make another one on 28 and see what can be printed. So you 3 and 2, right? Here.
Yeah.
So it means that the way that we call the pop here is correct, because this is the same way here. There is no change. But we are not able to print something meaningful when we do it here. Why?
Oh, well, because the one that worked is a stack of integers, while the one before that was a stack of objects.
Okay. So what we are printing here is just the address of the object in the memory. So it's not meaningful. So what do you think then we should do inside here to print something meaningful out of this stack with this pop command?
Use like a getter method.
So, okay, now my question to you, when I pop here, what is the result? When I do this pop, what is coming out of this? This is something coming out of data type what?
Integer.
Good. So integer, I'm able to directly print it using this print line, right? But the student object that I'm getting out, it's not printable. You're not able to print it. So you have to do something to be able to print that. So one method just to try, so you create here student S1 equal, and then yes, you're doing correct. Yes, perfect. Print. So you managed to get something, huh?
Yeah.
Good. It's excellent. So you managed to get out Alice Brown, is it true?
Yes.
But why Charlie is not printed? Suppose that you pop up from the last one, right?
Because of this. So if I get rid of it, then it say
yes,
Charlie.
You're correct. Yes. So I would like you to continue this code as an exercise until our next lesson. Okay.
Yep.
It's challenging, but I think you will learn something good. Okay.
Yes.
Okay. See you then next class.
Yep. Thank you.
Thanks.